Hello viewers, I'm Kausalya. Today we are going to discuss about chapter 10. The topic is circles. So now we start our lesson with theorem 10.1, right? So what is the theorem? The theorem says the tangent at any point of a circle is perpendicular to the radius through the point of contact. So here we are having two different terms, right? So one is tangent and another one is point of contact, right? So we know this is a circle, right? And radius is nothing but it is the line which joins center to the circumference, okay, whatever may be. So here for example, if this is a circle, right, and this is the center, right? So this line is also said to be radius and this line is also radius and this is also radius, right? So a line which joins the center to the circumference is known as radius. So the next thing is, what is a tangent then? So a tangent is nothing but it is a straight line that touches the circle at only one point, right? So here in this diagram, xy is a tangent, right? xy is a tangent and this touches the circle only at one point and that point is known as P here, right? Then the next thing is point of contact. So what do you mean by point of contact? The point that is here, the point P is known as the point of contact, right? The point where the tangent, okay, touches the circle, that is touches the circumference of the circle is known as point of contact, right? So here, what is the theorem states? The tangent at any point of a circle, okay, this is the tangent, is perpendicular to the radius through the point of contact. So here the thing is, the tangent at any point of the circle, this is the tangent, right, is perpendicular to the radius. So this is the tangent and this is the radius, right? We have to prove that this line and this line are perpendicular. That is radius and tangent are perpendicular through this point of contact, right? So you see, this is the circle with center O and xy is the tangent and P is the point of contact, right? So we have to prove that OP is perpendicular to xy. So now we are going to prove that, right? So here we are taking a point Q on the tangent xy. So you see here we are considering a new point Q on the tangent xy and we are joining this point Q with this O, that is to the center of the circle, right? Now this line OQ meets the circle at point R, right? So these are all the things we are doing, right? Now you see this OQ can be written as, OQ is nothing but it is OR plus RQ. Do you agree? And next, what is OR? OR is nothing but again it is the radius of the circle. So what about OP? OP is also radius, right? So as a first step you see here we have written OQ is OR plus RQ, right? And what is here OR? OR is nothing but radius. So we are replacing OR by OP because radius of a circle is always same. For example, if here it is 2 centimeter, then OR will be also equal to the same 2 centimeter, right? So we have replaced OR by OP. So you see, I have replaced OR by OP because OR is equal to OP. Why? Because they are the radius of the circle, right? Now, again we have to look back at the diagram and we have to check the dimensions, you see. Now we are going to compare OP and OQ, right? So from observation, we can tell that OQ is greater than OP. Say yes or no? Obviously yes, right? Why? So technically even we can define a little bit more also, but from the diagram it is evident, right? This is OP and this is your OQ. So obviously Here OQ is greater than OP, right? Or to prove more technically, you see OP is equal to OR because they are the radius of the circle here. And OQ is nothing but OR plus RQ, right? So if OQ is equal to OR, then it is okay. But here OQ is nothing but OR plus RQ, right? And this OR is equal to OP, right? So obviously here the value of OR is equal to OP, right? So obviously we can say that, right, OQ is greater than OP. Do you agree or not? Because here OQ is equal to OP plus RQ. There is an extra term RQ here. Right. So OQ is always greater than OP, or in other words, we can say OP is less than OQ. Right. Both holds the same meaning. So here, this is what I had written. OQ is greater than OP. In other words, OP is less than OQ. Right. So this is the condition that suits every point on the line XY except at P. That is, the value of OQ is greater than OP. Right. Same way, we will consider some other points and again we will recheck whether this condition satisfies. Right. So here we have taken OQ. Right. Now take some other point over here. Right. Okay, don't do this just in order to give a clear explanation, I am doing this. Okay, no need to do. So here for example, just I am considering another point and let this be Z here. Right. So when you compare the distances again OP and OZ, okay, let me draw a small line. No need to draw these things, right? Simply drawing the basic diagram is enough. I am giving an explanation here. So now look at OP and OZ. Can you tell which one is greater? Yeah, just by observing, you see OZ is greater than OP. Right. In similarly, you can consider any point on the line tangent. Right. When you consider all those lines, when you compare those lines with this line OP, finally OP will be the smallest line. Right. So in the same way, even if you keep dot over here also, because it is greater than radius, right? This is only radius, but it is greater than radius. So obviously OP will be lesser than the rest of the points. Right. So OP is the shortest of all distances of the point O to the points of XY. Right. So OP is perpendicular to XY. Right. We know that the shortest distance from a point to the line is the perpendicular distance. Okay. The shortest distance is always said to be a perpendicular distance to the line. So finally, we can conclude that OP is perpendicular to XY, right? So the remarks are, we can conclude at any point on a circle, there can be one and only tangent, right? Yes, because the circle has, you see, n number of points. For a single point, there will be only one tangent, right? The line joining the radius through the point of contact is also known as the normal to the circle at that point. So here the thing is, because here there is a radius and there is a tangent, right? So we can also say that the line joining the radius through the point of contact, okay? This is also known as normal to the circle at that point, okay? Again, a normal is nothing but it holds the meaning of perpendicular. Right. So that's all. If you have any doubt, let me know in the comment section. Thank you.